Hey guys, today we're going to be going over another pattern that's on pages 12 and 13 of your yellow Unit 3 workbook. Okay, so this is just like the kind of thing that we were doing on pages 1 and 3. 1 and 2, where we're using these figure numbers. We're trying to figure out a pattern, and then we're actually going to graph that pattern. Okay. So our first goal here, it looks like we're just talking about the total number of tiles, okay? So if I look at figure 1 and I count my tiles, I see I have 1, 2, 3, 4, 5, 6, 7, 8, 9 tiles in figure 1. All right, in figure 2, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right, in figure 3, I see 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay, so now I'm looking here for a pattern, and I see that each time it's going up by 6. Okay, so it stands to reason that this way would also go up by 6. We can use this same pattern to go backwards too and figure out that figure 0, right? If I go backwards, if this has to be plus 6, so I'm going to subtract 6, that means figure 0 would just have 3 tiles. Okay? Then we can use this to figure that figure 4 would have 27 and figure 5 would have 33. Now we're going to use these points, this information, to graph this on our graph down here. So our figure number in is going to be our x term, and then our number of tiles, the output, is going to be our y. All right, so my first term, or my first point here is 0, comma 3. So 0 for my figure number, and then I'm going up to 3 tiles. So my point will be right there. All right, next I have 1 and 9. So at figure 1, I'm going to go up to 9. Okay, figure 2. I'm going to go up to 15. So here's 2, there's 10, there's 15. Okay, next I have 3, comma 21. So figure 3 up to 21. Figure 4 has 27. So I'm going to go to figure 4 and then up to 27 tiles. All right, and then last but not least, figure 5 has 33. So from figure 5, I'm going to go all the way up to 33. Oh, I just lost my place. There. Okay, so I've got my figure numbers graphed. So I can use this rule to make some predictions. Here, let me connect a line. Okay. Sorry. So if I'm starting with 3 tiles, let me see if I can figure out how I need to. Okay. So if I'm adding 6 to each one, okay, I know that I need to come up with another 3 from somewhere to get to this 9. So if I think about it, to get from these numbers to these numbers, I'm multiplying by 3 and then adding. No, wait, that's not true. No, so sorry, I'm multiplying by 6 and then adding 3, right? I'm adding 6 each time, which means that's repeated addition of 6, which means I'm multiplying by 6, but then I have to do something to get from here to 9, right? Because 1 times 6 is 6, and then I know I need to add 3 to get to 9. 2 times 6 is 12, and then I need to add 3 to get to 15. 3 times 6 is 18, and then I need to add 3 to get to 21. 4 times 6 is 24, add 3 to get to 27, and so on and so forth. So my rule just kind of skipped ahead and we're going down to B over here on this side. So our rule is times 6, right? Our figure number times 6. And then add 3. All right, so if I'm trying to figure out figure 100, I know that I need to do 100 times 6. So 100 times 6, and then plus 3. So that would give me 600 plus 3, which means that figure 100 would have a total of 603 tiles. All right, and now since we've put our variables x and y to figure number and numbers of tiles out, right? We've got x and y. We can now use a rule. We can create an algebraic rule to describe this. So we are saying that in order to figure out my number of tiles, I am taking my figure number, I'm multiplying it by 6, and then I'm adding 3. But if we put in that x and the y, remember we said our total number of tiles is y, and our figure number is x. Okay, I get y equals x times 6 plus 3. But we also know that writing x times 6 means I should be writing 6x plus 3. Okay, and that is our algebraic rule. So our total number of tiles, right, is equal to 6 times the figure number plus 3. All right, and that is our algebraic rule for this pattern.